A NASA spacecraft is set to make history today, getting closer to the sun than any other human-made object.
After months of silence, NASA's legendary Voyager 1 has spoken again, and what it had to say sent a shiver through the scientific community. For a spacecraft that has spent over 45 years drifting further from Earth than any other human-made object, its sudden return to communication wasn't just welcome, it was seismic. The signal that pierced the silence was faint, battered by distance and the relentless force of cosmic radiation, but it carried data, clear, structured, unmistakably deliberate data. And what that data confirmed was precisely what many had feared: space. The deep interstellar space beyond our solar system is far more hostile, mysterious, and active than previously believed. Before we start, hit the like and subscribe buttons for more exclusive news. Voyager 1's journey has always been something of a miracle. Launched in 1977, its mission originally centered on flybys of Jupiter and Saturn, but its trajectory eventually led it out of the solar system entirely. For years, the spacecraft continued to send back data about the heliosphere and the interstellar medium. However, in late 2023, Voyager 1 began transmitting garbled messages, strings of unreadable code, as if its systems had been compromised or were deteriorating beyond recovery. Engineers scrambled to diagnose the problem, fearing the spacecraft had finally succumbed to age. Then silence. Months passed without a whisper from the distant probe. The revival of Voyager 1's signal in early 2025 was as unexpected as it was electrifying. The Deep Space Network picked up a coherent signal, unmistakably Voyager, transmitting a burst of compressed telemetry. After rigorous decoding, what emerged was not only a sign of operational resilience but also a trove of information. The spacecraft had recorded sustained, high-energy events, waves of unexplained particle surges, anomalous magnetic field distortions, and temperature spikes well outside expected parameters. The data showed that Voyager 1 had passed through a region of space that was turbulent, reactive, and unlike anything encountered before. It wasn't just an unexpected phenomenon. It was a confirmation of long-standing fears. For decades, scientists speculated about what lay beyond the heliopause, the boundary marking the end of our sun's influence. Some expected the interstellar medium to be relatively quiet, cold, and uneventful. Others warned that this space might be far more dynamic, shaped by cosmic rays, interstellar clouds, and perhaps even ancient energetic remnants from long-dead stars. Voyager 1's latest data left little room for optimism. The spacecraft had entered a zone dense with energetic particles moving at unpredictable velocities. Electromagnetic readings displayed fluctuations so intense they suggested proximity to massive shifting magnetic fields, possibly the relics of past supernovae or the periphery of a galactic-scale phenomenon still unfolding. The implications were immediate and daunting. First, the data dismantled the assumption that interstellar space was a largely static environment. Instead, it appeared to be a volatile, active realm, filled with unseen forces and dangers that could affect spacecraft, and in the longer view, potentially Earth. The interstellar clouds Voyager 1 passed through seemed to pulse with unexplained energy, potentially tied to gravitational anomalies or exotic forms of radiation. These weren't minor blips. The anomalies were sustained and powerful, capable of disrupting the spacecraft's instruments and possibly altering its trajectory. Second, the magnetic field distortions raised alarming questions. Voyager 1 is equipped with a magnetometer, and what it recorded looked like an ebb and flow of immense magnetic tides. These patterns didn't match known interstellar behavior. They suggested the presence of large-scale structures, maybe even colossal filaments or voids in the galactic magnetic web. Some readings indicated momentary spikes in magnetic pressure that couldn't be accounted for by existing models. One possible explanation was a nearby but undetected stellar remnant, perhaps a neutron star, pulsar, or a dormant black hole exerting influence from afar. That possibility sent ripples through astrophysics departments worldwide. If such objects are lurking near the solar system, how many others might exist in relative proximity, hidden from our instruments? But it wasn't just what the spacecraft encountered that was disturbing, it was the way its systems reacted. Voyager 1 is old, but its systems are rugged and have been consistently dependable. Yet, during its traversal of this volatile region, the spacecraft suffered brief system outages, as though it had been hit by something it couldn't completely withstand. Instrument logs showed microsecond lapses in telemetry, momentary data corruption, and, most unsettling, a brief delay in processor function that suggested time dilation or an electromagnetic disruption. While engineers are cautious about drawing conclusions, some theorists have speculated that Voyager, the 1st of May, have skirted a region of warped spacetime, a natural distortion, possibly a gravity well or exotic mass concentration capable of interfering with time-sensitive electronics. All of this has reignited conversations long considered fringe. Could there be massive, uncharted structures in interstellar space influencing the galaxy in ways we can't yet understand? Is the interstellar medium merely a chaotic plasma sea? Or is it shaped by larger, more organized forces? The data seems to point to the latter. Structures inferred from the magnetic patterns and particle surges suggest a kind of hidden architecture. Layers or veins of intense energy that extend for thousands, possibly millions of kilometers. This raises the unsettling possibility that space is not the empty vacuum we've long imagined, but a dynamic and hostile environment, one that we've barely begun to understand. Voyager 1's brief silence now feels even more ominous. During that blackout, the spacecraft was likely traversing the most dangerous region it had ever encountered. That it survived at all is miraculous. But what if it hadn't? We would never have known that these regions existed, never realized that the interstellar medium was filled with such volatile phenomena. Voyager 1 became not just a scientific instrument but a scout, risking total obliteration to send back warnings from the void. What also unsettled scientists was the change in background radiation levels. Voyager has always monitored cosmic rays and high-energy particles, but these recent readings were off the charts. Bursts of radiation flooded its detectors in irregular pulses, unlike any known source. They weren't constant, which ruled out typical stellar emissions, and they didn't follow the decay profile of ancient supernova remnants. This sparked immediate speculation. Could they be artificial in origin? Or perhaps worse, evidence of physical processes we have no existing model for. Adding to this, Voyager 1 recorded a steady hum, a frequency resonance within the plasma wave detector. It wasn't random noise, it repeated at intervals with fluctuations too precise to be dismissed as natural interference. Some dismissed it as a byproduct of the spacecraft's own systems struggling under environmental pressure. Others weren't so sure. A few dared to ask the most forbidden question: what if the signal was structured? Not a communication per se, but a kind of natural broadcast, space itself resonating with energy from a deeper layer of galactic architecture. The fear, then, wasn't just about danger, it was about ignorance. Voyager 1 has only scratched the surface of interstellar space, and yet it encountered forces so strange and powerful that our existing models failed to explain them. If such anomalies exist so close to our solar system, what lies further out? How frequent are these violent regions? Have we simply been lucky in our cosmic positioning, shielded by the sun's magnetic bubble from a galaxy far more dangerous than we imagined? These revelations force a re-evaluation of human ambition. Missions to interstellar space, once the dreams of optimistic futurists, now appear fraught with peril. If Voyager 1, a hardened probe with minimal needs, struggled to survive, how could a manned mission fare? Radiation shielding, propulsion, navigation, all would need to be re-engineered from the ground up. Interstellar travel may not just be difficult, it may be fundamentally hazardous in ways we didn't previously account for. The dream of reaching even the nearest star systems might involve navigating invisible minefields of energetic chaos, magnetic storms, and structural anomalies. Voyager 1's return has also sparked a kind of philosophical unease. Humanity often imagines the universe as a vast, silent expanse, beautiful, lonely, but predictable. This view comforted us. It made space feel conquerable, tameable. But what if space isn't empty? What if it's alive with turbulence, pulsing with forces that dwarf human understanding? The notion that our galaxy may contain energetic highways, magnetic abysses, or even spatial scars left by ancient cataclysms shifts the narrative from one of exploration to one of caution. Even within NASA, there are whispered conversations now about the limits of knowledge. Voyager 1 was never meant to be a sentinel, yet it became one. What it found suggests we are more isolated and more vulnerable than previously thought. Our instruments on Earth can only see so far. Our models are only as good as the data we feed them. And Voyager 1 just proved that we've been missing critical parts of the picture. If you liked this video, please give it a like and subscribe to our channel. Also, could you leave your comments below and tell us, what are your thoughts on Voyager 1's return? What do you think it discovered? We want to hear from you. Thank you for watching and see you next time.